We've spent a lot of time working on the designs of our database where we're taking a lot of really complicated data and separating it out into piles. Today, we're going to start ramping up our SQL skills and learn about multiple table queries, or as we would call them, joins, which is the way that we put all of that data back together again. So let's get started. After all the time that we spent splitting our really nice complicated data into separate tables, taking the metaphor of a chemistry molecule and splitting it into its atomic bits, it's finally time to put those back together again. And so what we're going to talk about in this video are these multiple table queries that can accumulate those atomic bits of data from different tables and put them all together again. Now the technical term for this is a join, and we're going to see more about that today. And we'll see that more in an upcoming video about different kinds of joins, but we'll get introduced to that today. Now, what I like to do is start with Bird Club because it's the one we're most familiar with. Here at the bottom is just the citing table. And as we designed it, remember it's a junction table that mediates between the person table and the bird table. And so you get two columns here of foreign keys, which we've called person ID and bird ID. Now, this isn't obviously all the information we would like to have. And so if I want to reconcile those foreign keys, like if I want to know who person 6 is, and I want to know what the heck bird 8 is, who they saw, which they saw, I need more than just the citing table, right? I have to reach out to the person table to figure out what ID 6 is and maybe retrieve some info there, like the names, for example. And then I have to reach out the other direction to the bird table to row 8, or ID 8, and then get some information, maybe the scientific name or maybe the common name. Here's a little bit of a design that helps us to see what's going on. If you can keep this in your head, all the better. If you need to have a picture in front of you as you're doing multiple table queries, that's fine. We're going to do one later that's kind of a little more complicated. So obviously, person and citing have a one-to-many relationship, and that's that nature of that trident. So the person is the one side of the trident, and the citing side gets the triangle, or what sometimes people call the crow's foot. And what that means is that one person can be involved in many bird sightings. But going the other way, every bird sighting belongs to only one person. And you can see that relationship is in the person underscore ID foreign key in the citing table. And similarly, the bird goes the other way too, right? Every bird can be involved in multiple bird sightings, but every bird sighting involves only one bird. And so the foreign keys in this design go on the trident side. So you know where the foreign keys go simply by what the picture looks like. And obviously, you see person ID and bird ID down here at the bottom. So let's talk our way through how we would reconcile those keys and how we would do a multiple table query, or what we were going to call a join. So the first thing that I do is that I just write down on a piece of paper. It could be a napkin at the coffee shop, anything you want. It could be your neighbor's forehead, whatever. And just write down all of the tables that you're going to need. Now, obviously, we're starting from the citing table and we're reaching out to bird and person. So we need all three of the tables in this example. And then I write down a bunch of the columns that occur in those tables. I could write down all of them or just some of them if I know I only want some of them, and I can be a little more efficient. And you'll notice that I put a dot in front of the column name. We'll see why in just a second. And then what I do is I draw boxes around the columns that I want to select. So in this example, I want to know the person's name, and I want to know the common name of the bird that they saw. So those are really the only three columns. Now, I could do a fancy thing, and I could concatenate the first and last name. Yeah, maybe we'll do that when we get to the terminal here. So I only want those columns. So I'm only going to have three columns in my final answer. And then what I do is I draw lines between the shared keys. So for example, in the person table, that .id is, if we remember, the primary key of the person. And the primary key of the person gets copied into the citing table as a foreign key where we call it person underscore ID. So if person number 7 sees a bird, we'll see a number 7 in the person table, and we'll see a number 7 in the sighting table under the person_ID column. And similarly with bird. So every bird has an ID primary key, and that ID primary key gets copied into the sighting table as bird_ID foreign key. So if you want to think about it this way, this is a metaphor I use a lot. These are like, every table is like an island in the stream, and the bridges are the things that allow me to move from island to island. So unless I have a shared key between person and sighting, I can't hop from one island to the other. I need to have a bridge to get there. So that's what those primary key, foreign key relationships do for me. And then finally I can write the query. Easy. Simple. And we know, too, that this is the structure of a query. It's always select from where. Select from where. And sometimes in the where clause we have multiple criteria. So there might be an and down there, there might be an or down there. It might actually get quite long in the criteria, but that's okay, no problem. So let's use that structure to piece together the query. So the columns that I want are 2 from the person table and 1 from the bird table. And you'll notice how I'm using this syntax here. It is the name of the table followed by that dot and then the column. That's why I write all of those dots down there. So in this case, I'm selecting person.first, person.last, and bird.common. So I'm telling MySQL 2 things. Number 1, which table do you need to look at? And number 2, on that table, which column do you want? Now, I need all 3 of those tables in order to jump from the island of person to the island of bird. I can't get from person to bird directly. I have to go through the sighting table. That's the only island, that's the only path through the forest that I have. So I need all 3 tables in my from clause, and I can just separate those with commas. So from person, comma sighting, comma bird. Now the one thing that I want to emphasize right now, you'll notice that I'm not right now selecting any column from the sighting table. That's okay. So the from clause is not the same as the tables in the select clause, right? I'm only using 2 tables in the select clause, but because I can't get from person to bird without going through sighting, I need to have the sighting table in my from clause. The where clause starts to illuminate or elucidate the bridges. How do I get from one table to the other? How do I cross the stream? How do I reconcile those primary foreign keys? Now, I usually start kind of left to right on this. If you want to go right to left, the order doesn't matter. So if I go left to right, the first one I do is from the primary key in person, so person.id, and that maps into the sighting table the foreign key called person_ID. So the values in those 2 columns need to be equal, but I have one more bridge to cross. So I add that in my AND clause. And again, I'm just going from left to right, but that's okay. You can do this in any order, right to left, scramble it up, whatever you want, doesn't matter. And then I'm going from the bird_ID foreign key in the sighting table, and I'm crossing the stream to the bird table where I'm matching or correlating that number to the ID primary key. And that's my query. Let's talk through that one more time, just to be clear, and then we'll do it in the terminal. I'm just going to do it on the diagram this time, but you'll already know where we're headed, right? So here's the diagram. Let's just do the same thing. So on the diagram, what I want are these 3 columns. I want the first name and the last name from person, and I want the common name off the bird table. I'll get, so select person.first, person.last, bird.common. Now I need all 3 of those tables because I can't get from person to bird unless I go through sighting. There's only one path through the forest here, and I have to go through the sighting table. So obviously I need all 3 of those, person and sighting and bird. Can I list those in any order? Absolutely. It doesn't matter one bit. I usually go, again, left to right, just to make sure that I'm, catching everything, but you can do it any way you want to. And then the where clause starts to map out those primary key, foreign key relationships. So here, obviously, we're going from ID in the person table to the foreign key in citing, and we're going from the foreign key in citing over to the primary key in bird. And that's all we need. That's our query. Let's take it out for a spin. I've already gotten into MySQL, and I have used Bird Club, so we're all ready to go. And let's just try and write this from memory. You guys can go back and look. But here's what I'm going to do. I'm going to do the fancy concatenation here. So I want to concatenate person.first with a space, and then person.last, and I'm going to alias that as name. And then I also want bird.common. And I'm going to select those from those three tables. So in my imagination, starting on the left was person, and then citing with the keyboard bounce is in the middle. And then I got bird on the outside on the right. And I need to put in my primary foreign keys. I'm just going to follow the same order. So the ID in person is primary key ID. On the citing table, that happens to be person_ID. And going from the citing table, keyboard bounce, from the bird, my keyboard, from the bird ID foreign key, and that goes to the bird table ID. There you go. So 27 rows in the set, because that's what we have in the citing table. And so all we've done is reconcile everybody's name to the birds they happen to have seen. Right? Now, we could add something to that if you want to. So I'm just going to go up, and I'm going to add citing .date to that. So now, in this case, I am in fact taking a column from all three tables, but I didn't need to. But obviously that doesn't change my from clause at all. Right? So if I can figure my way back out, there we go. So now we've got all of the dates reconciled. Let's talk through a second example. Let's imagine that I want to know who happened to have a bird sighting during the year 2018. Now, this is slightly simpler in that I don't need all three tables, because I don't need to know the birds they saw. So I'm going to eliminate the bird table from this particular query. But my process is exactly the same. So I'm going to start by drawing a box around the columns that I want. And since I'm looking for people, obviously I need something on the person table. I'm just going to do their first and last names, and maybe I can concatenate that again. And the one thing that's interesting now about this query is that I have some additional criteria. That is to say that I want rows from the citing table where the year of the date happens to be 2018. And so that needs to go in my where clause. So the where clause is not only going to do my primary key, foreign key relationship mapping, but it will also have the year of the date be equal to 2018. So we can write that query. So again, similar things. I'm going to concatenate the first and the last. I'm going to kind of his name. Yeah, we've seen that before. In this case, I only need two tables. I need the person table and I need the citing table. The where clause, again, maps out first that primary key, foreign key relationship, just as we saw before. But now it has this additional criterion that the year of the date column must be 2018. And so again, I know it's a full day, it's got a month, it's got a day. I'm just extracting part of that column. And so I'm using the year function here to extract only the year out of that date. Back in terminal, let's run that one. All right, so I'm going to do the concatenation again. So I'm going to concatenate person.first with a space and person.last. Wow, too much bounce. And I want to do that from both the person table. Oof, I'm having a hard time again, guys. And the citing table. Need both of those. Where Remember, two parts. So person ID equals citing foreign key, which I can't spell. And now I need that one additional criterion because I need to whittle down the rows. So where the year of the date column on the citing table happens to be equal to 2018. There we go. So I've got all of those people. Now I didn't have any additional information, obviously. I don't know the birds they saw. I don't know the dates specifically, but these are the people who were active in Bird Club in 2018. All right, another example. Let's find out which birds happened to be seen in the month of March. We don't care which year, just in March. Maybe we're tracking migration. Who knows? So in this case, we also need only two tables. In this example, I don't need to know the people who saw those birds. I just want to know the birds who were seen and in March. You can kind of see the structure that we've got. So again, I only want to know the bird.common. And in this case, on the citing table, I am going to enforce another criterion. That is to say that the month, once extracted from that date column, just has to be equal to March. So I can do that in two ways. I can do that as the number of the month, or I can do it as a string March. I'm going to do it as a string. And again, foreign keys, I'm going from the ID column in bird as the primary key to the foreign key in the citing table, etc., etc. It should be a familiar pattern by now, right? We can do that sort of stuff in our head. So again, to write that query, I'm going to select the bird.common. That's the only column I want in my answer. But I need both of those tables, so from both citing and bird. Again, can I do that in any order? Yes. And the where clause now does two things like it did before. I have to map primary key to foreign key, and I'm going to extract the month out of the date column and make sure that it equals March. Now, in this case, I'm going to use the month name function, which returns to me the text string name, and of course that's March. There are other functions I could use that would just extract the number of the month, so if that seems easier or more straightforward, you can use that, but I'm just going to go with the string version here. Back to our friend terminal. So now in this case, I'm going to select bird.common. That's all I want, I guess, from bird and citing. Again, you can do these in any order you want to. It's okay. The where clause needs to do two things. The first one is that I'm going to map out that relationship. I'm just going to go from the bird ID to the citing table, where the foreign key is bird_ID. And then the second one is that I want to extract the month name. Too much keyboard bounce. My keyboard is terrible. And the citing table, and that's the date column, and I want that to be equal to March. There we go. So only two birds were seen during the month of March in any year. Doesn't matter which year, but only two birds were seen. Let's look at a more complicated example. This is the Movie Lens data set. This is a study done by the University of Minnesota years ago. They collected 1 million movie reviews from about 6,000 people and about 3,800 movies or something like that. And so the user table maps a bunch of ratings to a bunch of movies, as you can see here on the top. So the rating table has over 1 million rows, and we're going to use that later in the class when we start to work with things like indexes and how to work with bigger data that slows things down a little bit. Just a quick preview about this table, which we'll look at in other ways too. The original study mapped a few demographics, and so they had a chart for people's age. So you're like, say 1 to 18 years old, and then maybe 19 to 24, and then 25 to 30, or whatever. So we don't know their exact age, but they do fit into a kind of categorized taxonomy. So I've just built age as a separate kind of lookup table here. And the same for occupation. So if you're in the education field, that's one key. If you're in a lawyer, that's another one. If you're in the health profession, that's a third one, et cetera, et cetera, et cetera. So those are just age and occupation are just lookup tables. And you can see that I have mapped those as foreign keys into the user table. But every rating at the top belongs to a particular movie. That's in the top right-hand corner here. And we don't have much information about the movie. We only have the title and the year. Now, the original study made a decision. And they said, should a movie have only one genre, like comedy, drama, action, documentary, whatever? Should it have only one genre, or can a movie have multiple genres? So can it be, Harry Potter is an action movie and a documentary and a thriller all at the same time? And they said, yeah, that's fine. So every movie can belong to multiple genres, and every genre belongs to multiple movies. So there is a many-to-many relationship between movie and genre. And what that means is that we have to have a junction table to mediate between those two. We have to have the junction table to reconcile the keys in a many-to-many relationship. Now, in this case, we called that table movie_genre. Now, it doesn't correspond to a real-world entity. All these other tables map to a real-world entity, but that one doesn't. And it needs to be there because otherwise we can't manage the many-to-many relationship between movies and genres. So because it doesn't have a real-world entity, we just invent a name, and we just call it the two tables separated by an underscore. But it still has to be there. It's an interesting example of understanding the design and knowing when you put a junction table in there, even if it doesn't map to something in the real world. All right. So let's examine this query. We won't do this in the terminal window, but you can practice it if you want to, if you've loaded up the Movie Lens database. I just want to know which are the favorite genres of movies among women. Now, it's going to involve a whole bunch of tables here, but again, I'm jumping from island to island in the stream, or if you want to use a different metaphor, I just need one path through the forest. So what I need is the genre of the movie, which is down in the bottom right-hand corner, and I want to see what those are, and I'm going to count those up. But I also have another criterion here, because I don't care which ones men like, I just want to know which ones women like. So on the user table, I need to look in the gender column, and I need only those rows in the user table where the value in that column is F. So that's really similar to the kinds of queries we were just doing. It's just that this one has way more tables. Okay, so how do I get there? What's my path through the forest? Well, okay. If I start on the user table, I can map from the primary key on the user table to a foreign key in the rating table. So that's a primary key, foreign key relationship, and you can follow the trident line there. That would be another path. So now I need to move farther, closer to the genre table. So what do? Well, I've got the movie foreign key, which leads me to the primary key in the movie table. Good. And you see where I'm going. Now I can go from the primary key in the movie table down to that imaginary junction table called movie_genre, where I also have, once again, the foreign key for the movie. And then my last hop is going to be from the foreign key of the genre back to the primary key in the genre table. And then I can count those up. So we'll do the query. There are some parts here that if you're doing all of these videos in order, we might not have seen yet. And you're welcome to practice this one on the command line in the terminal window on your own. So what I want to do is I want to select the genre and then how many of those appear in movie ratings by women. So I just want to count them up. Remember our rule, don't store anything in the database that you can calculate or count. And because I can count the number of genres rated by women, and I can see which genres are rated more often by women, I just want to count those up. Yeah. Now look at the from clause. I need all of those tables, right? I am only doing 2 columns in my select clause, but I need all of those tables. So I need left to right, the user table, the rating table, the movie table, that imaginary junction table, movie_genre, and then the genre table itself. And I need all of those in order to work my way through the forest to get to where I want to be. The where clause, because I have so many tables, is going to be a little bit bigger too. And so again, I'm just going to start on the left, and in any direction you want to go to is fine. So I want the gender to be F on the user table. And then from the user table, I can go from the primary key over to the foreign key on rating. And then I'm going to go from the foreign key on rating to the primary key on movie. And then I'm going to go from the primary key on movie to the foreign key on movie _ genre. And then I can go from the genre foreign key down to the primary key on the genre table. That's good. So that gets me through the forest. That's the labyrinthine path through the maze that gets me through all of the tables that I need. Now, I'm going to add a few more columns on here. Then we'll talk about these in a later video. I need to group those, and then I'm going to order it by the count descending. So the most popular genres are at the top. So if you've loaded up the Movie Lens database and you want to play with this, go right ahead. There's the query, and you can just pause the video and you can jump in and do it. And if you do it, this is going to be your answer. So drama, comedy, romance, action, thriller, those are the popular to least popular genres, at least in this study that was done by the University of Minnesota. Now, you might have noticed something clever if you were paying attention. I can go directly from the rating table at the top directly to the movie _ genre table, and I can skip the movie table entirely. And that's because the rating table has a movie foreign key, and also the movie _ genre table has a movie foreign key. So I can actually take a shortcut through the forest, and I do not need to touch or go through the movie table. Is that legal? You bet. It is great when you find a shortcut like this, but they do not always exist. And there's nothing wrong with just continuing to follow the primary key, foreign key relationships. But in this particular case, I can in fact omit one table. Does that help MySQL? It sure does. We're going to see why in just a minute. So again, I'm not going to do this one in the terminal window, but if you like to do this, you can just pause and feel free to play with it. All right. A little technical chalk talk. That is to say, how does this actually work under the hood? Now, if you want to skip this part, feel free. If everything that we've talked about so far makes sense, that's great. However, I think understanding how a join actually works makes you write better queries because you understand how the pieces fit together. The short answer is that it's a 2 or 3 step process, but we're going to create something first called a Cartesian product, and then we're going to filter the rows. So we're going to talk through an example here, and I'll show you how that works. Now, the underlying geometry of every MySQL table and every MySQL multi-table join is, believe it or not, a Venn diagram. MySQL thinks of every table as a set. And when we do a multiple table query or a join, what happens geometrically is that MySQL overlaps these two circles, or it could be 3 or 4 or 5, in the Venn diagram. And what we're actually looking for, believe it or not, is that middle football shape. That's what we've been doing this whole time, even though we didn't really know that we were working with sets. And that's an intersection. And you can see here on the left, I've written down sort of the template of the query. So we've got select, blah, 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 some fields from some table on the left and a table on the right, where there is some ID or primary key, foreign key relationship, something, 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 right? Now, technically, these are called inner joins. And the reason they're called inner joins is because we're looking for the intersection of those two sets. We're looking for the middle part. We're looking for the inner part where they happen to overlap. Now, conversely, and I'll show you in a minute, we could look for stuff that's not in the middle, and those are called outer joins. But we're not going to do any outer joins in this video. We'll do one later. All right. So what happens? I want to step through this, and I just want to show you images here from the terminal window how this works. So when we join two tables, the first thing that MySQL does is to create what's called a Cartesian product. So let's just take a quick example. I select star from person and citing. This is really similar to what we were doing in one of our earlier examples. Now, I've left off the where clause so that you can see what MySQL produces. And you can see that the 5 columns on the left are from person, and the 4 columns on the right are from citing. And it actually puts those together in one giant table. Now, this is an intermediary table. It is not the final answer, but this is the first step that MySQL does in a join. And now there's a particular pattern here, and maybe you can already see it, but I'll highlight it. Notice that on the left, all of the rows in white are the people from the person table, 1 through 17. Just as we would see them if we did select star from person. But look at the green stuff on the right. That's only the first row from the citing table. That has ID 1. That's ID 1 from the citing table, in which person number 1 sees bird number 1 on 2017-03-22. And you can see that that record number 1 from the citing table is repeated 17 times, once for every single person in the person table. Now, like it scrolls off the bottom, but you can see that pattern repeated down here. MySQL goes through every single person in the person table again a second time, but now it maps every single person to record number 2 out of the citing table, where person number 1, subbird number 3 on 2018-11-14. And that goes all the way through this giant Cartesian product table, all the way to the bottom where it looks like this. Yet again, one more time, we see all 17 people from the person table here on the left in the white. But now the green, on the left, the green on the right is mapping to row 27 in the citing table, where again, person number 1 sees bird 14 on 2017-11-15. And you'll see here at the bottom of the MySQL, output, it says there are 459 rows in that set. And if you do the math, there are 17 people in person and there are 27 sightings, and so 17 times 27 is 459. So this is the master set. This is the Cartesian product of every person combined with every row. It has all the potential possibilities. So the next step is that MySQL goes to the where clause, and it goes through that Cartesian product row by row, and it applies the where criteria to each row, and it determines whether it should keep that row as it works towards the final answer, or whether it should discard that row and eliminate it from the final answer. So let's just look. So again, select star from person where the person ID happens to equal the foreign key in the citing table. Now, the person.id is the column farthest to the left. And you can see the citing person_ID foreign key about third from the right. So all MySQL has to do is to match the numbers in those two columns. And when they match, it keeps that row. If they don't match, it discards that row. And you can see here in the white, there are only 2 rows that we can see in this part where those numbers match, right? And they're both Robert Smith's. So Robert Smith is ID 1, but his key shows up in the person_ID column. So his primary key on the left matches the foreign key on the right. Now, MySQL is just comparing the values in 2 rows, and that's why it doesn't matter which order we put those in. If I reverse the order and I look for person_ID first, and then the primary key ID second, that's totally fine. MySQL is just looking at columns in a row of the Cartesian product, and it's comparing values in 2 columns to see if they're the same. And that's all it's doing. Now, the only rows that will be kept as it works towards the final answer are those in white. Every row in yellow will be discarded because the primary key does not match the foreign key. And here's what we get. So if we actually allow MySQL to do that query, now we're back to 27 rows, which makes sense. That's how many there are in the citing table. But you can see in the white here that every value in the ID column matches the corresponding value in the person ID column. So as you read across those horizontally, those numbers match. 1 matches 1, 1 matches 1, 6 matches 6, etc., all the way through. Well, now if we added more criteria to the where clause, MySQL just repeats the process. This now is the current working answer, but if we had more criteria, MySQL would just apply those criteria to this table. So let's do that. Here's the one that we were working on. Let's imagine that we want any bird sighting that happened in the year 2018 or later. So we just add a new criterion to our where clause, and MySQL repeats the process. So now it goes through this table row by row, and it checks to see if the year is 2018 or more. And you can see all of the rows here in white will be kept as it works towards the final answer, and all of the rows in yellow will be discarded. And that gives us the final answer, which is here. So of those 27 rows in the citing table, 16 of them show up in 2018 or later. Now, I've still done the select star here, but I could obviously, of course, select fewer columns. I could just get the first and last, or maybe I want the first and last and the date on which they saw the bird. Who knows, right? But select star is useful because it shows us the whole structure of the Cartesian product table, and I think that helps us to understand how MySQL works through an answer. And once you know that, you can write queries, I think, more efficiently. Yeah. Now, I'm just going to leave this with you as we depart. What we were talking about today is what was called an inner join. And of all the possible overlapping Venn diagram intersection stuff that you can see here, the one we were working on is the one in the middle. Everything we've done so far is an intersection, and it looks for that football shape in the middle. Now, all of the others on here, you'll notice the red, when we keep data, we're keeping some data that is not necessarily always just inside that little inner football shape. So because we're keeping data from the outside of the football shape, all the rest of those are called outer joins in some sense. Now, in an upcoming video, we're going to do what's called a left join, and that's going to involve those two parts of the diagram on the left-hand side. And we'll talk a little bit more about joins and how all of these joins work. But for right now, everything that we've done is the inner join, which is that middle diagram right there. All right, well, that's it for the long and arduous journey of inner joins. So go away, practice those, get really good at it. The more you do them, obviously, the easier they get. And stay tuned for a later video where we'll look at those elusive left joins, and we might even look at a right join. Right? Thanks.